Students, the topic for the day is dynamic memory allocation for two-dimensional arrays. And this is the outline, the various things we will discuss, like lecture outcomes, then the topic itself, and next the summary part, and lecture outcomes revisited, and finally the problems and further references. So, lecture outcomes, after completion of this lecture, students will be able to understand the concept of dynamic memory allocation for two-dimensional arrays, and also they are able to apply and use this two-dimensional arrays concept in various real-time applications. So we already know a two-dimensional array generally it is declared in this way, where int ARR is the array name and the number of rows and number of columns. But thing is, when we declare the array in the traditional way, in the normal way, it's like the memory for this array will be allocated at compile time. So if you want to change it during runtime, it cannot be changed. So if you want to change the declared array during runtime, and also to allocate the memory of this two-dimensional array during runtime, we have a concept like dynamic memory allocation, and we have certain functions also which are used to dynamically allocate memory. So we have functions, we already discussed this in the previous topic, like we have 4 functions to dynamically allocate memory for an array so that the memory allocation is done during runtime, or we can say execution time. So the functions available are malloc, calloc, realloc, and free. And we had discussed how malloc can be used, and how calloc can be used, and also realloc and free in the previous topic. And here we will look at how a dynamic memory allocation can be done for a two-dimensional array. So previously we had seen for one-dimensional array, and in today's class we look at memory allocation for a two-dimensional array. So for a two-dimensional array, generally we will go with a array where we declare it as a pointer to a pointer, because this will store address of another address. So to store memory for two-dimensional array, we treat it as array of one-dimensional arrays. So we treat a two-dimensional array as array of multiple one-dimensional arrays. So to store addresses of multiple one-dimensional arrays, we allocate the memory in this way, malloc into the rows into size of int. So each one-dimensional array becomes one row. So if you want 5 rows in a two-dimensional array, so we write the malloc of 5 into size of int. So in this way, we will allocate memory so that we can store addresses of multiple one-dimensional arrays. Next, to allocate memory for the actual one-dimensional arrays, so if we want to allocate memory for 5 one-dimensional arrays, we keep a for loop which runs from 0 to 4, that is 5 iterations. And inside the for loop, we will write this statement. Array of 0 is equal to, for the first row, memory is allocated. Next is array of 1. And for the second row, memory will be allocated. Array of 2. Next, memory for the third row will be allocated, and so on. And after allocation of memory, if you want to store values, you can normally use ARR as you use in normal two-dimensional array. So you can write like ARR of I and J, I value and J value. Okay, so it's a normal way of storing the values and printing the values can be done. And at the end, we must remember that we need to free the memory whatever allocated using this malloc functions. So this is a program for the same. You can go through. So this is this statement is to store addresses of one-dimensional arrays, and this is storage of memory for each one-dimensional array. This for each row memory allocation, or for each one-dimensional array memory allocation in this multiple iterations of for loop. So this part is memory allocation for two-dimensional array, entire two-dimensional array, and next storing of values we will do the normal way using the array name and in the nested for loop as with a scanf statement. This is a normal way we are done. We do in the normal arrays, two-dimensional arrays. So normal way of storing values. This is the regular way, or because the normal way of printing the values from a two-dimensional array. And at the end, freeing the allocated memory. Okay. So to summarize, we need to remember that a two-dimensional array is treated as a array of multiple one-dimensional arrays. There multiple one-dimensional array becomes a each row in a two-dimensional array. Okay. So here we will end up, and the lecture outcomes revisited. Like we are able to understand dynamic memory allocation for two-dimensional array. We are able to apply this concept in our real-time applications. Thank you.